In this video, we're going to talk about exponential growth and exponential decay. So last time we talked about the function f of x equals b to the x, where b is positive and not equal to 1. Let's see what happens if you increase x by 1. Let's see what happens to f of x. So in other words, let's say that you have some old value of x, like 5 or something, just some number, and then you add 1 to it and you get this new x value. So you start off with the old value and add 1 to get this new x value. So the question is, how are f of the old x and f of the new x related? So let's call f of x sub old y sub old. So your old y value, and then f of x new is your y sub new, that's your new y value. So the question is, when you have these old and new y values, how are they related? Well, if I have f of x sub new, so if I plug in my new x value, that is what I get when I plug in the old x value plus 1, because that's what the new x value is. It's the old x value plus 1. Well, that is b to the x sub old plus 1. Now I have this property. Remember that exponential functions have this property that b to the something plus something, so like maybe x plus y, whatever, is b to the x times b to the y, right? B, where x and y are any real numbers. So if I apply that to, here, I have an exponent that's a sum. This is b to the x old times b to the 1, which is, well, b to the x of old. That's just what I get when I plug in my old x value into the function. So that's the old y value. And what I'm calculating is the new y value. And then, so it's the old y value times b. So now you see what the connection is. When you increase x by 1, so when x increases by 1, we compare y sub new is equal to y sub old times b. So that means when x increases by 1, y gets multiplied by b. So it might help to just look at an example. So like, let's say that you have f of x equals 3 to the x, right? And I want to compare f of 4 and f of 5. Well, f of 4 is just 3 times 3 times 3 times 3. F of 5 is 3 times 3 times 3 times 3 times 3. So how do you get from f of 4 to f of 5? You multiply by 3, right? Well, it's the same. That's the same thing that happens whatever your x is, like not necessarily 4 or 5 or whatever, just whatever number x is. When you increase x by 1, y gets multiplied by a factor of b. So if f of x is 3 to the x, every time x increases by 1, f of x increases by a factor of 5. In other words, it triples, right? And so this can be used to describe what f of x equals b to the x does. Because if you have f of x equals 5 to the x, what this means is that f of x gets multiplied by a factor of 5 when x increases by 1. So you could also have something like, well, your b could also be less than 1 as long as it's positive. So let's say that you have 1/2 to the x. Well, then f of x gets multiplied by a factor of 1/2 whenever x increases by 1. Well, what's another way of saying gets multiplied by 1/2? In other words, it gets halved. So yeah, your y values get halved every time x goes up by 1 when your function is 1/2 raised to the x power. Now when you look at these functions, remember f of x equals b to the x has the property that when x is 0, so f of x equals b to the x has the property that when x is 0, f of x is 1, right? Because b to the 0 power is 1. Now in general, you can have the function f of x equals, say, a times b to the x. This is also sometimes considered an exponential function. So not just b to the x, you can multiply it by a constant. It's also considered an exponential function. And it also has the property that if I plug in x plus 1, I get a times b to the x plus 1 power, and that's equal to a times b to the x times b. And a times b to the x is f of x, so I have b times f of x. So again, every time I increase x by 1, my y value gets multiplied by b. Notice that what we can say about f of x, one way to interpret a is what you get when you plug in 0. So f of 0 equals a times b to 0, b to 0 is 1, a times 1 is a. So we can interpret, when we have a function f of x equals a times b to the x, we can interpret a as what you get when you plug in 0, and we can interpret b as, so we can interpret b as what you have to multiply y by whenever x increases by 1. So that's sometimes called the growth factor when b is greater than 1, or the decay factor when b is less than 1. And again, throughout b is positive. So that's a term when you have an exponential function. Growth factor and decay factor, that's just b in your a times b to the x. So if b is 3, your function is tripling every time x increases by 1. If b is 2, then your function is doubling every time x increases by 1. If b is a third, then your y values are getting multiplied by a third every time x increases by 1. So whatever b is, whenever x increases by 1, your function gets multiplied by b. Your value, your y value, gets multiplied by b. That's how you can interpret b. So that's why it's a growth factor or decay factor. Okay. So that's how you interpret b in your a times b to the x. And remember, a is just, the way to interpret it is what you get when you plug in x equals 0. So if you think of x as representing, say, time, okay, then when x is 0, you would get a. That would be like your initial value. Okay. So here's an example. Suppose that something increases, so sales of something increased 12% per year since 2000. Okay. Now we're not even doing a problem, we're just thinking about how to translate the sentence into a saying something about a function. So how do you represent this sentence mathematically? So let's talk about what increased 12% per year means. So 12% literally means 0.12. Right? It means 12 divided by 100, that number. But when you say in English, something increased by 12%, what it means that if you have some number, like sales, like say it's some number, okay? When it increases by 12% per year, that means that each year the number of, maybe we'll call it y, each year y gets increased by 12% of y. Not the number, 12%. It means 12% of the value. So what that means is that y, so you start with y and then you increase by 12% of y. Well, 12% of y is 0.12y, right? And so you get 1.12y. So in other words, if sales at a certain year is y, so y dollars, then next year sales is 1.12y. You multiply by 1.12. So does that remind you of exponential functions? Because when you have an exponential function, a times b to the x, your values get multiplied by b every time x goes up by 1. So here we're saying that whenever your year increases by 1, you get multiplied by 1.12. So suppose, let's say that you have a starting value at 2000. Like, let's just make a table with a year and sales. Now the problem doesn't say how much sales were in 2000, so let's just give it a number. Let's call it A. Okay. So this is, let's say that T is years since 2000. So T would be 0 in year 2000, and let's say sales is A. Okay, whatever it is, it's at 2000. At year 2000, it's A. So 1 year from 2000, so when it's 2001, it says sales got multiplied. It got increased by 12%. Increased 12% is the same thing as saying that it got multiplied by 1.12. So sales when t is 1 is 1.12a. What about when t is 2, 3, and 4? So when t is 2, that's 2002. Well, sales again got multiplied by 1.12. So in 2001, sales were 1.12A. Okay, then you multiply that by 1.12 to see what sales were in 2002. So that would be 1.12 squared times A. And 1.12 squared times A is 1.2544A. Then to see what happens in 2003 and 2004, so each year you multiply by 1.12. That's the point. When it says increased by 12% a year, that means that each year it got multiplied by 1.12. So to go to the sales in 2003, you again multiply by 1.12. It's actually easier to, instead of actually writing out what you get, let's just write it as 1.12 cubed, because 1.12 squared times 1.12 is 1.12 cubed. So you have 1.12 cubed times A. And that's as simplified as you can make it without actually calculating 1.12 cubed. And then when t is 4, you multiply by 1.12 again, so you get 1.12 to the 4th power times A. So what would it be like n years from 2000? So when it's year 2000 plus n, well, if you continue the pattern, right, each time you're multiplying 1.12, so it'd be 1.12 to the nth power times A. Or you can write as A times 1.12 to the nth power. It might be easier to write like this with the parentheses just to make it clear what's going on. Okay? And of course, your function is going to depend on what sales were in 2000. Because that's what's telling you what A is. So yeah. So suppose that A was 1500. Okay, that's the initial sales. Then your function would be f of n equals 1500 times 1.12 to the n power. So in general, if you have some quantity increased by, say, X percent a year since, a certain year, okay, whatever. And in that year, the quantity was A, okay, then in n years, okay, what would you have? Well, so initially you have A, and then each year you multiply by X percent. So X percent, but you're multiplying, so what you're doing is you're adding X percent of A, so X 100th times A. Each year, right, you're increasing by X over 100 times the previous amount. So this is going to be 1 plus X over 100 times A. So this is after 1 year. Then this is going to be the amount. Okay. And after n years, each year you're multiplying by 1 plus X to the 100th. So you end up getting A times 1 plus X over 100 raised to the nth power. So that is the quantity that you have. And this is an exponential function because it's A times some constant raised to some variable. So here it's like my variable is n, right? N is the number of years since my initial year. And this would be exponential growth, because if you increase by X% a year, right, then you're increasing. So that's exponential growth. You have growth and it's multiplied by an exponential function, that's exponential growth. And so our growth factor, to use that term that we had before, our growth factor, our B, is 1 plus x over 100. So in the previous example that we had here, the growth factor would be, what is the growth factor? 1.12. So you could say that when sales are increasing 12% a year, that's exponential growth with a growth factor of 1.12. Let's talk a little bit about exponential decay. So exponential decay is when b is less than 1. And that happens when you have a decrease. So suppose that, again, sales were, instead of increasing, they were decreasing by 5% a year. And let's say that initially, say at a certain year, sales were $A dollars, right? Then what would happen after like n years? So what are the sales after n years? Well, if you decrease by 5% a year, okay, what that means is, so if you start with a certain amount, like A, so this is the initial, then after 1 year, what happens? You decreased by 5% of A. So you subtract 5% of A, of the initial amount. Okay, so when you have A minus 5 over 100th, that's 95 hundredths A. So that's, okay, that's because it's 1 minus 5 over 100 times A. And then after 2 years, so each time you multiply by 0.95, now after 2 years, you have 95% of what you had after 1 year. So you multiply by 0.95 of how much you had after 1 year. So that's 1 minus, let's write it as 1 minus 5 over 100 instead of 0.95, times the 1 minus 5 over 100A that you had after 1 year. Right, so this is the amount after 1 year. And then you multiply by 1 minus 5 over 100. So this is, and then you just keep multiplying by 0.95 and you keep going. So then after n years, you are left with 1 minus 5 over 100 to the nth power times n. So this is the amount after n years. Right? So you have A times 1 minus, so if you decrease by, instead of 5%, let's say that you had X%, right? Whatever percent, then you would have 1 minus X over 100 raised to the nth power times A. So that is your function that tells you the amount after n years. Where you start off with A and you decrease by X% a year. Okay? And where n is the number of years. since your initial amount. If instead of years you had months, then n would be in months, but you would have the same formula. So this would be exponential decay, because you're subtracting a positive number from 1. So 1 minus x over 100 is less than 1. Right? So you have an exponential decay with a decay factor of 1 minus x over 100. So in this case, your b is 1 minus x over 100. So that's how exponential functions are related to exponential growth and exponential decay.